Welcome to Basic Concepts of Physics YouTube channel. Dear students, I hope you all are very well and studying very hard. So today I will discuss about an interesting property of liquid called surface tension. So first of all, we want to know what is surface tension. So students, in few cases we must have noticed that if we placed a needle or a blade on the surface of the liquid, it is found to float on the surface of the liquid. In other cases we also have noticed that few insects walk on the surface of the liquid or walk on the surface of the water very easily. From all these facts we can easily understand the liquid surface. The surface of the liquid behaves just like a stretched elastic membrane. So we can say that all the liquid wants to keep its surface under a constant tension, just like a stretched elastic membrane, to occupy minimum surface area, and this property of the liquid is known as surface tension. So I can write all the liquid wants to keep its surface under a constant tension, just like a stretched elastic membrane. Just like a stretched elastic membrane, to occupy minimum surface area, this property of liquid is known as surface tension, but the question is, why liquid surface wants to keep its surface under a constant tension? Why the surface of the liquid behaves like a stretched elastic membrane? Why it wants to occupy minimum surface area? Why liquid drops or raindrops are spherical in shape? This is our main topic today. We will discuss more about on it later. Before going to the explanation of surface tension, we need to know about some intermolecular, we need to know about intermolecular force. So, according to the molecular theory, we know that matter is made of particles, tiny particles, and this particle is known as molecules, and every molecules attract each other, by a force. So this force is two types. This force is the force of attraction between the two molecules is two types. One is cohesive force, one is cohesive force, and another is adhesive force. So what is cohesive force? If the force of attraction between the molecules is in the same substance, then that force is known as cohesive force. So cohesive force is basically the force of attraction of the molecules of same substance. যদি এটা সেম সাবস্টেন্সের মধ্যে হয়, সেম সাবস্টেন্স, আর এটা হচ্ছে, আর in adhesive force, the adhesive force, if the force of attraction between the molecules of different substances is in different substances, this force of attraction is known as adhesive force. It is different for different substances. This force of attraction between the molecules of different substances. So these two are the intermolecular force acting on the two molecules, which is maybe same substance or may be different substances. So, and now these two intermolecular forces are quite different from gravitational forces. These two types of intermolecular forces are quite different from gravitational forces. It doesn't obey the inverse square law. And the range of this force of attraction, is of the order of 10 to the power minus 9 meter. That means of the order of nanometer. And this force of attraction basically is within the range of 10 to the power minus 9 meter. That means if the distance between the two molecules, here it is a molecule, if the distance between the two molecules is greater than 10 to the power minus 9 meter, then that force of attraction is negligible. Then this force of attraction is negligible. And this force of attraction, these two types of intermolecular force of attraction is applicable when the distance between the two molecules is 10 to the power minus 9 meter or less than 10 to the power minus 9 meter. Then this force of attraction is applicable. So we can say that the maximum distance up to which the force of attraction between the two molecules is applicable, this distance is called as molecular range. It is also called the molecular range. Because up to that distance, up to 10 to the power minus 9 meter, this force of attraction is applicable. If the distance is greater than 10 to the power minus 9 meter, this force of attraction is negligible. So that distance is known as the molecular range. So we now discuss about the explanation of surface tension. It is our main topic today. So, we will study explanation of surface tension. Main topic, our today's main topic, explanation of surface tension. Explanation of surface tension. Laplace first explained the phenomenon surface tension on the basis of intermolecular forces. And we see in the previous case two intermolecular forces, we discussed about this in the previous case. Here for example, a cohesive force, the force acting between the molecules of its molecules. Here the molecules are all the molecules are of same types. So this force of attraction is an example of cohesive force. And for example of an adhesive force, if we power some liquid on the glass plate, we see that it weights the glass plate. To explain this phenomena, we know about the concept of adhesive force. Here this happens because the particles of the glass plate or molecules of the glass plate attracts the molecules of the water. So that is why water weights the glass plate. It is an example of adhesive force. Here to going to the before going to the I want to discuss about the surface tension on the basis of intermolecular forces. In order to understand the tension acting on the surface of the liquid, we consider a container. There are some water container. We take a container, there are some water or liquid. In order to understand this tension acting on it is the free surface of the liquid. In order to understand the force or tension acting on the surface of the liquid, we choose three molecules. First, which is designated by A, B and C. We choose three molecules designated by here, another is here and another is here, designated by A, B and C. A, B and C. Here first we look at the molecule A. This molecule, the molecule A, is well inside. This molecule I choose here is well inside the liquid. This molecule A is well inside the liquid. So the molecule is attracted equally in all directions. This molecule is attracted by the surroundings molecules in all direction. and this force of attraction is equal in all directions. We can see, we can show that by an arrow. This molecule is attracted equally in all directions by the other molecules. So, the net resultant force, this is attracted equally in all directions. So, the net resultant force acting on the molecule is 0. So, the net resultant force acting on the molecule is 0. If we go to the molecule B, here we notice that the number of particles top of the molecule is less than that the number of particles bottom of the molecules. So, this molecule is not attracted equally in all directions, and the molecule B is just below the surface of the liquid, just below the surface of the liquid. So, the number of molecules on the top of the number of particles on the top of the molecule is less than that of the number of particles bottom of the molecule. So, it is not equally attracted in all direction like that. Oh, here is a net force, here acting a net force in the downward direction. We see that it is not attracted equally in all directions. It is not attracted equally, and there is a resultant force, there is a resultant force acting in the downward directions. There is a resultant force or net force acting in the downward direction, F net, in the downward directions. So, for if we see the molecule C, next we see the molecule C. Here the molecule C is in the surface of the liquid. So, there is no molecule on the top of the, there is no particle on the top of the molecule C. All the molecules are at the bottom of the, all the particles are at the bottom of the molecule. So, here the force of attraction on the molecule C is only on the downward direction, is only in the downward directions. So, here also a net force, here also a net force acting on the particle in the downward direction, but this net force acting in the downward direction acting on the particle C or molecule C is maximum, because there is no molecule on the top, there is no particle on the top of the molecule. So, here for the molecule C, the net force or the resultant force acting on the molecule C is greater. So, from this diagram we easily understand that the molecules which are lying in the surface of the liquid, the force of the net force acting on it is maximum force acting on it, maximum downward resultant force acting on it. So, the molecules which are lying in the surface, to maintain its position and maximum work is done against this downward resultant force to maintain its position. So, the molecules to maintain its position, a maximum work is done against this downward resultant force to maintain, only for maintain it, to maintain its position, just for maintain its position. we can easily understand from this diagram those things, easily understand those things from these diagrams. Now, if we increase the surface area of the liquid, so what happens? If we increase the surface area of the liquid, what happens? The number of molecules, the molecules from the interior of the liquid rise to the surface. If we increase the surface area of the liquid, what happens? Molecules from the interior rise to the surface of the liquid. If these molecules lying near the surface of the liquid and work is done against this downward resultant force, the net resultant force acting downward, but the molecules will give rise to the interior molecules rise to the surface. When we increase the surface area, the molecules from the interior rise to the surface. So that means the molecules which rise to the surface and work is done against this net resultant force, and this work is maximum to the molecules which are lying on the surface, right? So because the net resultant force acting on the molecules which are lying on the surface is maximum, this force of attraction is maximum for the molecules which are lying on the surface of the liquid. So the molecules which rise to the surface and maximum work is done against this maximum downward resultant force, and this work is maximum for the molecules which are lying on the surface compared to the interior molecule, and this work done will store as a potential energy inside the molecule. This work done is stored as a potential energy inside the molecules. So the molecules lying on the surface has maximum potential energy, because maximum work is done for the molecules lying on the surface. There is a maximum resultant force, maximum work is done against this resultant force to maintain its position. So maximum work is done means this work done is stored as a potential energy, as this work done is stored as a potential energy. So we can say that the molecules lying in the surface has maximum potential energy compared to the molecules compared to the interior molecules, because interior we see that when the molecules is well inside, the net resultant force acting on the particle is 0. That means these molecules has no potential energy, no external work done is needed, no work done is needed for the molecules. That means there has the molecules which are lying well inside, they need not do some external work. That means they have no potential energy. So the molecules lying near to the surface has maximum potential energy, but we know that a system is in stable equilibrium when its potential energy is minimum. A system is in stable equilibrium when its potential energy is minimum. So to minimize its potential energy, the liquid wants to keep minimum number of molecules on the surface. To minimize the potential energy, the liquid wants to keep minimum number of particles on the surface, as we see that the particles at the surface of the liquid has maximum potential energy. So, to minimize the potential energy, the liquid wants to keep minimum number of molecules at the surface of the liquid. In other words, we can say it that liquid surface wants to minimize its surface area, That means minimum surface area means minimum number of molecules at the surface of the liquid. So, that is why the liquid wants to keep its surface area minimum, That is why liquid surface behave just like a stretched elastic membrane to minimum its potential energy, or to occupy minimum surface area. So, that is why raindrops are spherical in shape, because for a given volume sphere has a minimum surface area. For a given volume sphere has a minimum surface area. That is why the liquid surface is, or liquid drops or raindrops are spherical in shape. So, I hope this video will be very helpful to all of you. If you like this video, please subscribe my channel. So, that is for today. See you in the next video. Bye bye.